when Praveen came over and asked me if I would talk about this, some sports analytics and so on, I said, sure, that's what I do, that's what I teach, it's something I really love. And then he hit me with, well, we're going to have a competition about the Australian Open. And I said, oh, well, I don't know how that's going to change what I have to talk about. And then Craig comes along and says, I'm going to bring somebody from emergency medicine, you know. And I said, oh, so how am I going to get that into the talk? So it's gotten a little bit complicated and so on. But it's, you know, I'm going to talk sort of fairly general. I was part of a session at MIT and ESPN put on a conference every year, and I ran a session on teaching sports analytics, and I presented there. And then recently at Informs, we had a session with people. And so I've stolen some of the things that I've heard, and Mike was at that session, so he has to put up with some of that. And some of the things are new. Stop me anytime you want, ask questions. Now, you know, it's interesting that we're going to be predicting the Australian Open. Here we're coming. If I mention to you, do you know of any, Sean, do you know of any big sporting event that's going to come in the winter? Would you pick the Australian Open? What would you likely pick?
NFL playoffs?
Super Bowl, NFL playoffs. No, it's Australian Open. Nevertheless, that's who we are. So we'll go with that. So this is this was for the emergency medicine. There's a lot of sports statistics out there, and you're going to see some of it. I actually teach a couple of courses here, one called Sports by the Numbers, which is essentially an undergraduate course, and a course called Bracketology, which I'll offer this spring. And this has both a mixture of undergraduate and graduate students, and deals with the NCAA basketball playoffs. This is a brief outline. I'm just putting these things up here as an introduction to what I do in the Sports by the Numbers class. And you can see I have several visitors. Mike's a visitor to the class. There's some people who are involved in sports consulting. I have our UC athletic director came. Paul Bezier is a graduate of our program, of this program that you're in right now, and he has a company called PredictionMachine.com, and he's done pretty well in terms of predicting. Jeff Smith is a consultant for the Bengals. Dick Williams and Sam Grossman work for the Reds. We've had an interesting, you have to memorize that. And then in the bracketology class, it's only done 3 Saturdays in the spring. And in the first Saturday, we sort of talk about the tournament and talk about rankings and how you go about doing that and how you get the probabilities and fill out your brackets. And I'll talk about some of that today. Then in the second class, we actually simulate what the committee does in picking the teams. So the groups, this class is broken up into committees, and they actually have to figure out, based on all the data, who should be playing who, what the bracket should look like. And then the third class is after the tournament is over, and we have some guests. Joe Lunardi is the person from ESPN who's actually started the term bracketology, and he visited the class, and we see how people have done. And I think the great story here is that we have a competition in the class, and Paul and myself, who are the 2 instructors, and the students are entering into this brackets competition. And the student who won last year never saw a basketball game. He used strictly the analytics that he learned in making the picks. Well, we all have biases, you know, about, oh, this team always does well, and this coach was really good at the end of the season, and stuff like that. He didn't know any of that, you know. He wound up winning the competition and the big prize that we offer. So let me talk a little bit about sports. We have different sports structures. Sometimes we have certain games that whoever scores the most over a period of time win. it is a challenge for some of these to figure out what sport we're talking about. Some of them, you know, is when you get to a certain point, if you won a certain number of points, you've won. When you play table tennis, if you typically get 21 points, you've won the game. Then there's the subjective scoring that you have in diving and skating and things like that, and how far you can throw something, how high you can jump, things of that type. And then there's cumulative points. So in baseball, you look at the end of a certain amount of times people get up at bat and so forth, and you see who scored the most runs. And then there's some that who does something the fastest. It's usually the fastest, not usually who does it the slowest. But, you know, and scores are usually the highest, but in golf it's the lowest. So you have different kinds of things like that. Then you have different kinds of tournaments. We're going to talk about elimination tournaments. That means you play in the tournament, and then if you lose, you're out. And that's typically the case in tennis. It's not always in tennis, but at the end of the season, they do have a round robin, actually, that takes place. But, you know, where everyone plays everybody, or at least, and they pick then the ones who've done best, and they play in the semifinals and the finals and so on. And then there's some where you just, over a long period of time, over several tournaments, you calculate points, and it's the end of the season or something like that that you determine the winner. There's different kinds of structures. So what are the kinds of things we can do? One of them is we can analyze players, individuals. We can see how good their season was. We look at the physics of how much they've moved. We can see if there's streaks that have occurred, what kind of medications have worked for the players. There's all kinds of things. Salaries are an obvious one, but we can look at a player level analysis. Another is we can look at a team analysis. How well did the team do? What are the strategies that we used in the in-game decisions? What kind of transactions did they have with respect to trades and their drafts? And for those of you who don't know, most of the professional sport teams draft amateur players, typically college players, at a certain period of time in some different sequences that they have. Scheduling is a problem that is very related to what you learn in your optimization classes, and how to decide a fair way of having different teams play other teams. And for certain sports, it's relatively easy. If you have a sport that's a power of 2 in terms of the number of teams, if you don't have to worry that much about travel distance, like in professional football, they play once a week. It's getting less than that now, isn't it? Because they have Thursday games, and you know, they have all that other kind of stuff. But it's essentially, you don't worry about travel that much, playing in London. Where in other sports, you know, travel's a big thing, and so forth. So this becomes a very difficult combinatorial problem. Baseball has 162 games, and trying to schedule that is a huge problem. And people in our field have been very successful in working on these kinds of scheduling problems. People have done simulations of sporting events. People have developed board games of different sports. Then there's this whole economics of sports. You know, ticket pricing, all the marketing activities. Fantasy leagues is a huge thing right now. Gambling, so forth. So there's a lot of economics there. How do you find data? What are the data sources? How do I capture data is certainly something, all the media activities. So there's a lot of things when we talk about this. And if you talk about sports in a much more general setting, and this university has actually talked about having sort of a sports institute in some sense, you could think about the sociology associated with sports and the medical aspects. Almost every part of the university, in some ways, you could think of an intersection that people could have with sports. So it's very inclusive. Anyone have any questions about, because I'm talking in very general terms right now, some of the terms I use. I once, I teach the sports by the numbers class, and when I talk about baseball and so forth, I would spend time and I'm going through this whole thing about whether RBIs are really important and so forth. I spent a lot of time talking about RBIs, and then a student from another culture came up to me after the class and said, "What's an RBI?" Okay, so I lose track of what terms are very, very familiar. An RBI is a run batted in. That's one statistic that exists in baseball. So if I'm using some terms you're not familiar with, you can just stop me and I can go back. So the methodologies we do use optimization, mathematical programming, data visualization. When the Reds come, one of the things they show is what's called hot zones and cool zones for the pitcher and the batters. There are certain places that a batter can hit the ball very, very well, and other places they don't hit it well. And what they show is, and if you just try to explain that to a Major League Baseball player or a manager, they may have a hard time. So you show them this picture, and you have some of it in red, and some of it in pink, and then some of it in light blue, showing, and then you get the feeling of the hot and cool and so forth. So the whole data visualization is a very, very important part of this activity. Since sporting events have a lot of uncertainty associated with it, we often model these with probabilistic assumptions, develop stochastic processes. We do that. I'm including simulation and so forth in there, and I think you guys have mostly taken simulation this semester, and we'll be taking optimization for first-year students. I think next semester. A lot of statistical modeling. We got a lot of data. What data is important? How do we make decisions from the data? And decision analysis. Sometimes we have some big decisions to make. Is it worth spending $75 million to add a few seats to our stadium, for instance? Something like that. We might have some kinds of questions of a very, very different nature. So, one of the things about sports is we tend to be able to model these with a state space consideration. Baseball is very easy. We look at how many men are on base, we look at how many outs. And if we're trying to predict winning and losing, we might want to know what inning it is, we might want to know the score. All right? I'm going to make assumptions that you know something about these sports. And if you don't, I can explain, but that's all right. American football gets a little more complicated. You have yard lines, you have down, you have score, you have time left in the game or time left in the half. You have timeouts available and all kinds of stuff like that. So the state space is a little bit more complicated. And similarly, in basketball, tennis, soccer, you can always describe things by what's existing on the field as a state. All right? And then you ask some questions. And one of the things is, how Markovian are these things? You know what I'm talking about when I say Markovian? No. All right. I'll give you an example, and I'll give you an example in a minute. The other thing we want to do is use these state spaces to develop prediction models. Given we're in state I, which might be a vector, multidimensional, what's the probability of moving to state J? All right, so you're in certain places, what's the chance you're going to move somewhere else? If you know baseball at all, and there's 2 outs in an inning, you can't move to 1 out in an inning. You can stay at 2 or you can move to 3. Those are the only possibilities. And then you want to ask, what's the probability of winning? given I'm in a certain state? So these are the kinds of things we want to ask. So I'll use tennis. This is where I've had to augment based on the request. All right, so this is a game of tennis. And you start off with 0-0. They actually call it what? Love, love, right? 0 is love. And then you move to 15 love, or you move to love 15. All right, from 0-0. And this is your state in that game. And then from 15 love, you can go to 30 love, or 15 all, and so forth. And when you get to a point, you're at 30-30, which is called deuce, and someone wins a point, then someone has the advantage, add. All right, so it's either 40-30 or 30-40. Then you can go back to deuce, because you have to win by 2 points in the game, and then you're either going to win or lose. Okay? So let me ask you, maybe I'll wait with my Markovian thing. So the state here is represented by the score, and you can see we can move from certain states to other states. We can't move from 15 all to love 15. We can move from 15 all to 30-15 or 15-30. All right, so that's a game. Then we can do the same thing for the set. You have to win 6 games to win the set, but you have to win by 2. All right? Unless you're in a situation where it becomes 6-6, and then you could play something called a tiebreaker. All right? And somebody wins the set 7-6. So you go from 0-0 to 1-0 to 2-0 to 2-1. You can see the possibilities. So these are the number of games, which we just described in the last slide, that you have in the set. So let's take a look at let's take a look at this state 5-5. And I'll ask the question. There's different ways I could reach this state, right? One is I could win the first game, second game, third game, fourth game, fifth game, and then lose the first game, second game, third game, fourth game, fifth game. Another is I could lose the first 5 and win the next 5. Or I could win the first one and then lose the next one, so forth. There's lots of paths you could see to get to 5-5. Now if this is a Markov chain, the Markovian assumption is that it doesn't matter how I got to 5-5. My chance of going to 6-5 or 5-6 or winning the set or not winning the set doesn't matter. Now what do you think? Think it matters? You think it does? So you think it's a difference when you go 1 love, 2 love, 3 love, 4 love, 5 love, and then you lose 5 games, or if you've lost the first 5 and then you win the next 5, why? Why would it be different?
The confidence level of the player.
Confidence level of the player. So you've won 5 games in a row, you feel things are going well. All right? You know, do you think I can take a coin, I think I have a coin, and I can flip it 5 times and get 5 heads? Sure. And then I could flip it 5 more times and get 5 tails, right? So do you think the next one is more likely to be a tail? Because I just flipped it and had 5 tails. You do. You think the coin is confident? The tails are confident? I don't know. Maybe it's different, right? People. So it's a hard thing to know. In certain scenarios, you say that momentum really matters. You build momentum. And in other cases, you can show statistically that you get these streaks, and it has nothing to do with momentum. It's going to happen. Teams win several games in a row, and then they lose several games in a row. It doesn't mean, some people believe it's a fallacy that teams are hot. You think the Philadelphia 76ers are in a random situation right now? Probably not, right?
I think they're terrible.
Oh, okay. There's a basketball team that has lost 17 games in a row to start the season. The record is 18. They have a good chance of getting there. And it's not 50-50, it's my guess. All right? But often in doing the analysis of these kinds of things, we do make assumptions that things are Markovian. And it changes, how you do the analysis. So once you've now won a set, you now want to win the match. And a match is in almost all tournaments 2 out of 3 sets. But in the majors, which the Australian Open is, it's 3 out of 5 sets. You have to win 3 sets to win the match.
For the men, that is for the men.
Being a little sexist.
That's the men. That's right. Well, I think the tournament was going to be on the men. For the men. The women have to win 2 out of 3. And one questions why the women make as much money as the men. Well, I won't go into that. There was a big fight many years ago, the women saying they should make as much money as the men when they weren't making as much. And the men said, why? We have to play so much more. In some of the tournaments, if you go to Wimbledon, in fact, they don't have tiebreakers in the last set. And they had one match with John with John Isner that went 63-61 when it ended. 3 days later. All right. So, I wanted to show you at this point something. All right. So this is the tournament from last year. This is the men's 2014 Australian Open bracket. This is what a bracket looks like. Now I'm at a bracket now that I'm in the 4th round. It starts off here. There's 128 players, and some of them have seeds. Some of them are ranked high, and that assures them that high-ranked players won't play other high-ranked players early in the tournament. So they separate. So here you see last year, Nadal was ranked number 1. And then if you go to one of the other brackets, you'll see you have the 4th seeded player. And on top, and here you'll have the 3rd seeded player here, and so forth. It assures that the ranked players don't play each other early on. All right? So this is what a bracket looks like. So this is the 1st round, 2nd round, 3rd round, 4th round. You get to this point, and then you get to the quarterfinals. So each time you have a winner. And then you get to the semifinals where there's 4 players. And then you get to the finals, which has 2 players, and you get a winner. And last year, Stan Wawrinka won, and he was seeded 8th. Typically, the seeds correspond to their world ranking, but sometimes there's a little deviation from that, and so on. So this is essentially, if you're going to pick, and I don't know exactly how you're going to do this, but you'd have to pick the winners of, if you have 128 players, you can't answer. If you have 128 players, how many matches are there? Let's see, we have to do, how is it 2 plus 4 plus 8? How many players are there? How many matches will you have if there's 128 players in order for the tournament?
Somebody said it.
What?
2 power 7 minus 1.
What is it?
2 power 6. That's 227.
127! How'd you get that? How'd you get 127?
2 power 7 minus 2
minus 1. 128 number of players minus 1.
Right. If you have 128 players, 127 are going to lose. So you have to have 127 matches. Now, you can also do 2 to the k minus 1, but, just thinking of it that way is a lot simpler. I'll actually talk about that a bit. So this is sort of the structure we have. Let me go back to this a bit. I just said this. Tournaments with K rounds start with 2 to the K teams, require 2 to the K minus 1 games. In basketball, you have 6 rounds, 64 teams, 63 games. You actually have not a power of 2 right now. They're up to 68, which makes it a little complicated. The number of realizations of how this can unfold is a huge number. It's more than 9 billion ways it can unfold. Last year in basketball, there was an offer made if someone could pick all 63 of the games, the winners of all the basketball games, that they would be given $1 billion. All right, and the first weekend they played, where they played 2 rounds, it was all over. Nobody had picked them all. It ended quickly. All right? There's so many possibilities. And imagine for tennis with 128, the huge number of possibilities. So, again, I don't know if you're planning on starting at the beginning and asking them to pick every match, but the number of possibilities is tremendous. And I will give someone who picks all 127 matches an A. So what we're going to do instead, because it's too many to look at these possibilities, I'm going to assume we're down to just 4 players rather than 128. So we want to predict winners. So what we have here are the numbers represent the probability that the row player beats the column player. Okay? And I have what's ranked as my top 4 players. Djokovic is playing Wawrinka. Djokovic is now ranked number 1. Wawrinka is 4. Federer and Nadal 2 and 3. And these are the probabilities that one player will beat the other. All right? And this is the kind of analysis we have to do. Djokovic plays Wawrinka, Federer plays Nadal in the semis. So picture that brackets we had, and then the winners play. What's our goal? And that's one of the questions you're going to have to ask. What is the goal? Is it to pick the number of correct matches, or is it to pick the winner? If you're only interested in picking the winner, it's different. All right? So if I wanted to pick the number of correct matches, I would ask, what is the best picks to maximize the expected number of correct picks? So that I would answer with something like Djokovic beats Wawrinka, Federer beats Nadal, and Djokovic beats Federer. That's one possibility. There's 3 matches. All right? And there's 8 of those possibilities. And you could calculate the expected number of matches you get correct. You either got 3 correct, 2 correct, 1 correct, or 0 correct. And you could calculate those probabilities, those expected values. The other thing is, I'm interested in knowing only who wins the tournament. I want to maximize the probability that I pick the winner. So I want to look at the probability that Djokovic wins. Well, it means he has to beat Wawrinka, and then he's going to beat Federer if Federer beat Nadal, so it's a conditional probability. Or he's going to beat Nadal if Nadal beat Federer, and so on, and we can do those calculations. All right? Relatively simple. Simple for 4, 128, a little bit more cumbersome. But given these probabilities, we can start doing these calculations. And it turns out to maximize the expected number of wins, we would choose Wawrinka, Federer, and then Wawrinka. And we would have the expected number of wins is 1.35. That's how many matches we would pick correctly. Interestingly, if we wanted to pick the winner, we would choose Nadal. And the probability Nadal wins is he'll win 32% of the time, 0.32. So what I find interesting about this is that what you'd say the player in the best position to win wouldn't be someone included if you wanted to pick the greatest number of wins. And when you fill out brackets in basketball, what happens is you want to be able to look at, because that's what I'm familiar with, you want to be able to look at who certain teams are going to play to get to a certain point. They're going to have some tough matches early on. All right? And it may be less likely they get there. They may be the best team, but they'll have to work hard to get to that point. All right? I might be the best tennis player here, but if I have to play every one of you, by the time I get to you, I'm going to be exhausted. Right? Besides, I know you're an expert in tennis. So, another thing about depth points. Sometimes the later matches are worth more. Sometimes you would say in the first round, it's worth 1 point for everything you get right. Second round, it's worth 2 points, and so on. So, if we have something where it's 1 point for our semifinals and D for the finals, it turns out if D is less than 20/7, we would pick the Wawrinka Federer Wawrinka. But when D gets large, we're better off picking anything with Nadal. It doesn't matter. Doesn't matter who wins the other one. Yeah?
What is D here?
Sorry?
What is D here?
It's a number. In other words, you, or you, whoever is putting this together, is going to say every first round match you get correct, you're going to get 1 point. Every second round match you put together, you're going to get D1 points. D2 we'll call it. And in the third round you'll get D3 points. And D4, whether it's a power of 2 or whether it's an arithmetic progression, whatever it might be. D is the number of points you get in the later rounds. So, the key here is that I have probabilities. I have a probability of any player beating another player. Where'd these come from? It all hinges on these probabilities. Well, we have huge amounts of data in tennis. So what are the kinds of things you'd want to know? You'd want to know how often 2 players played and who won, right? That's some way you could figure out the probability that one player would beat another. You might want to know what surface they played on, because if you play at Wimbledon, you're in grass. You play in France, you're on clay. You play in US or Australia, you're on a hard court. And certain players play better on certain surfaces. Maybe when, last week, last year, injuries. So there's different things that can influence these probabilities. You can use simulation, right? I look at the data and I simulate the events occurring. So one of the things you might use in doing this is what's called the rankings. So here are the current rankings in men's singles. All right, Djokovic is 1, Federer 2, Nadal 3, Wawrinka 4, and so on. Goes to hundreds, goes down to thousands. All right, and you can see the points that they've accumulated. Now you get points based on how far you've gone in a tournament. And certain tournaments are worth more than other tournaments. The most of the majors, and then there's a set of Masters tournaments that also have high-level points, and one of them takes place in Cincinnati. All right? So even though you're doing this now, don't forget this summer to go up to Mason and see all of these players. There's usually one or two that are injured. But essentially, all of these players will be there. All right? You can see them right here in town. So you can use this ranking. So if I say, what's the chance that Joe Willie is going to be David Farrar, you could say, well, he's 12, he's 10, he's accumulated this number of points. You could use these numbers in some way in trying to figure out probabilities. Right? So you have some things that you might be able to use. Because remember, everything is dependent on these probabilities. So I've done so much more in college basketball than I have there. And there's lots of things that they take into account there. Things like what's called strength of schedule. Now, it's sort of different. But there's also some similarities. Strength of schedule means how good are the teams that they've played. Because if you lose to another high-level team, it shouldn't hurt you as much than losing to a weak team, maybe. So it's who they beat, who they lost to, maybe how much they won by, how much they lost by. Was it home? Was it away? Home field, by the way, is a huge influence in most sports. There's a big home field advantage. And when did they lose? Beginning of the season? You take college sport, like college basketball, and you look at teams who win the championship, and they really peak at the end of the year. Connecticut won last year. We split with Connecticut during the year. Or did we beat them twice?
Actually, yeah,
I think we beat them twice. They became the national championship, the national champion. Well, they got better and better as the year went on. Well, maybe we got worse and worse. No, I think they got better and better as the year went on. And they peaked at the right time. So when did this happen, this match? So if you think about it with respect to tennis, one of the things that happens, did you see those brackets I put up? And you saw that in the first round, the number 1 seeded player played somebody. That poor guy. All right, that poor guy. And by the way, after the first 32 seeds are there, everyone else is randomly chosen about who they play. So some poor guy is going to play Djokovic in the first round. All right, and they never win. They never win. And should they be penalized as much as that? Let's say that same guy wound up playing another nobody and lost. Should they be penalized the same? I don't know. If that same guy lost to Djokovic, but let's say he lost in the third set tiebreaker, you'd say, boy, he was close. All right? Maybe, he should get some consideration. Doesn't matter in terms of the rankings. He lost in the first round. That's all anyone looks at. And so there's all kinds of things you could do if you wanted to spend the time with these 128 players that you're going to see about who they played, when they lost, by how much they lost. There's an awful lot of data that you can have. And you have all the data. All right? Good luck. All right. In basketball, there's some simple things you can do. Here's one. Probability that I beats J is J over I plus J. All right? You take a 1-seeded player. You take a 20th seeded player. All right? The probability that the 20th seeded player beats the first seeded the probability that the first seeded player beats the 20th seeded player is 20 over 21. I don't know, simple. Of course, in basketball, the first seeded teams have never lost to the 16th seeded teams in the first round. One that gets a little more complicated, and then one that gets even more complicated. We start talking about some percentiles of normal distributions and so forth that we get in order to figure out these probabilities. All right. This is a one that seems to do really well. It's called logistic regression in Markov chains. It was developed by some folks at Georgia Tech. And what it does is say, given that Team A has a margin of victory against Team B by X points, so they played at home and they won by X points, they ask, what's the probability that Team A will beat Team B on the road? Because they know what the advantage is of being at home. Given these road win probabilities, what's the probability that A will beat B on a neutral court? Because in the tournament, theoretically, they're playing in neutral courts. So from this, you develop all these probabilities that we're looking for. So you do it using logistic regression. You look at all the different things that could influence whether someone wins or loses. And you take the home field advantage, which is H, and you calculate these, and then you put them into a Markov chain, and you calculate the steady state probabilities of the Markov chain, and you wind up using that to figure out the probability that Team I can beat Team J. Remember when we did our little exercise, we already had those probabilities in there. You use whatever you want, simple rankings, whatever you want as your probabilities, but somehow you got to come up with who's going to win the bracket. Okay, so with respect to tennis, there's not an awful lot of analytics. There's one thing that says, you know, when you serve in tennis, you get two serves. If the first one is a fault, you get a second serve. And there is some work about saying, do I try for my hardest serve on the first one? Because if I miss it, I have a better chance of double faulting. If I let up a little, I have much less chance of double faulting, and that might be a good thing. So there's a little bit of that. There's some things also, there's some game theoretic stuff about in college sports where you put certain players. I'm the captain of a tennis team. And being the captain of a tennis team simply means that they needed someone to do work, and I said yes. It doesn't mean anything about being a quality player at all right? But I have to pair up players. So we have a first court, a second court, a third court, and a fourth court. In principle, the first court's the best, then the second, then the third, and then the fourth. But if I'm playing another team, I really want to put, and I know their first player is really good, maybe I should put my worst player there on the first court. All right? Maybe that will increase the number of matches I win. Now, it's not illegal to do, but we try to avoid it if we can. Lakshmi, there you are. Her problem. Well, one of the things in tennis, this is a tennis court, by the way. These are distances. And as I mentioned, there's different surfaces. Well, when you play on clay, one of the things that has to happen is that the lines have to be brushed. Because you can't see them. The clay covers the lines. And they have to be brushed. And when I play with a colleague of mine, a fellow named Ken Baker, who's at Dartmouth, and he and I meet in Boston, and we play on some clay courts, they require that you brush them yourselves. In most places, they have people that do the brushing for you, but they have to brush them yourself. So if you get two operations research people doing this, they naturally ask, what is the optimal way to do it? How do I brush the lines? And if I'm playing doubles, I have to have these lines done too. Singles, you don't worry about these, but in doubles, you worry about these. How do I brush the lines and walk the minimum distance? And it has taken us a year to work on this problem. All right? And we had the whole thing solved until I sent it to Ken, and he said to me, You can walk like that. And we never even thought about it. We were always walking on the lines. So now the whole Euclidean distance thing has to be considered in doing this. It has nothing to do with the tournament, all right? But it's just another problem where you can use analytics in this kind of activity. Well, that's all I got.